IUPAC names of carboxylic acid compounds. The carboxylic acid have the carboxyl group, that is COOH, as a main functional group present in the molecules. Therefore, the general formula for the acid compound is RCOOH. They are further classified according to number of acid group present in these molecules. According to the IUPAC nomenclature rules, the IUPAC names of this acid is derived from parent alkane by replacing E of the parent alkane by oic followed by word acid. In case of branched chain acid or unsaturated acids, the carbon atom of the COH group is always numbered as 1, and in case of unsaturated acid, the anionic is replaced by enoic acid. Other rules are same as that of for saturated acids. In here, the first example of acid containing molecules, the numbering start from the acid containing carbon atoms. Therefore, the number to the acid containing carbon atoms 1, 2, 3, 4, 5. In this molecule, there are 5 carbon atoms. Therefore, the corresponding alkane of the 5 carbon atom is pentane. In the pentane, you can E replaced by oic acid as a suffix. Therefore, the name of this molecule is pentanoic acid. For the cyclic molecules, you can numbering from the cyclic molecule, that is 1, 2, 3, 4 number of cycle atoms. Like here is a 6-membered cyclic molecules which contain acid group present. Therefore, according to IUPAC nomenclature rules, you can write cyclohexane at a prefix and then carboxylic acid at a suffix. Therefore, the name of this cyclic compounds is cyclohexane carboxylic acids. Now here second example, here is one substituent, that is bromine substituent present in these molecules, and the main functional group, that is acid group present in this molecule. Therefore, you can numbering from the acid containing carbon atoms. Therefore, this carbon has 1, 2, 3, 4, 5, 6. Now here total 6 carbon atom present in these molecules. Therefore, the corresponding alkane of the molecule is hexane, and this molecule contain one substituent, that is Br substituent present in the carbon number 5. In the IUPAC nomenclatures, the at a prefix you can write the number and name of this substituent. Here is bromine substituent. Therefore, the location of bromine is 5. The 5-bromo hexanoic acid is the correct IUPAC name of these molecules. Then second example, there are again two substituents and the both terminal substituted with the acid groups. Therefore, here is a chlorine substituent as well as bromine substituent. There are two different substituents present in these molecules. Therefore, according to alphabetical order, the Br, that is bromine, is first, then chlorine. Therefore, the numbering start from this left to right. These are the 1, 2, 3, 4, 5, 6, 7 and 8, and here is a 2 acid group present. Therefore, you can use word, that is di, for the two same groups. Before the name of this molecule, at the prefix you can write the 3-bromo dash 6-chloro at a prefix, then 1,8-dioic acid. These are the correct IUPAC name of these molecules. Here again there are two practice example. You can write correct IUPAC name of these molecules and then send answer of these compounds. Now these are the derivative of acid, that is acid anhydride. Here the main functional group present, that is COOCO. These are the main functional group present in the anhydride molecules. In the IUPAC nomenclature, you can replace acid by anhydrides. Now the first example of these anhydride molecules, here these are the symmetrical anhydride. Therefore, the name of this IUPAC name of this molecule is ethanoic anhydride. For the unsymmetrical molecule, you can write the smaller uh, carbon atom as at a prefix and then larger carbon acids at a suffix. Like these are the practice example. Here is unsymmetrical example. Next derivative of acid, that is acid halides. In the acid halide there is a main functional group is COCl. In this molecule the acid, for example, the acid halides, they derived from acid by replacing OH group of carboxylic acid by halide molecules, any one halide that like chlorine, bromine. These are the mainly halide used. They are named by changing the ending IC acid of the corresponding carboxylic acid to YL chloride. IC acid is replaced by YL plus name of these halides. The first example of acid halide, here there are 3 carbon atoms, therefore the propane system, that is propanoic acid. From the propanoic acid the IC acid is replaced by halides. Here is bromine, therefore the propanol bromide. These are the IUPAC name of this molecule. For the cyclic compounds you can use the word cyclo and the number of carbon atoms. In here there are 6 membered carbon cycle system, therefore cyclohexane carbonyl chloride is the IUPAC name of this molecules. Here again these are the practice example. You can write correct IUPAC name and then send answer image of these molecules. The next one, that is ester's derivative. Here again the OH group is replaced by OR group. Their name consists of two words. That is, the first word is the name of the alkyl group attached to the oxygen atoms, and the second word is the derived by the carboxylic acid name with IC acid changed to ATE. That is, IC acid replaced by ATE. And in the ester there are RCOR is a main functional group. The first example of ester groups. Here in the IUPAC nomenclature, in the ester molecules there are two words used in the IUPAC names. The first word, the alkyl group attached with the oxygen atoms, these are the at prefix and then the corresponding acid of this molecule. Therefore here the first word CH3 group is attached with oxygen atom, so therefore that is one carbon atom, that is methyl, and the remaining group, that is the remaining group which contain number of carbon atoms are 3. Therefore the IUPAC name of this molecule is methyl propanoate. The propanoate is from the corresponding propanoic acid, that is IC acid is replaced by ATE. Therefore the IUPAC name of this molecule is methyl propanoate. In the second example, in this molecule these are the symmetrical compounds, that is diethyl butane di OATE, that is these are the IUPAC name of these molecules. Now here the oxygen substituents, the oxygen, the first word, the oxygen content, that is these are the ethyl groups CH2 CH3, and these are the two molecules, therefore diethyl, and the remaining group, that is butanoic acid butane dioic acid. Therefore the IUPAC name of this molecule is diethyl butane dioate is correct IUPAC name of these molecules. Then next derivative of acid, that is amides, the OH is replaced by NH2 groups. In the IUPAC names you can replacing the oic acid by ending amides. The first example, here there is only one carbon atoms, therefore the corresponding acid of this molecule is methanoic acid. From the methanoic acid the oic acid is replaced by amide, therefore the name of this molecule is amide. There is only one carbon atom, so therefore the corresponding acid of this molecule is methanoic acid. From the methanoic acid, OH is replaced by NH2 group. Therefore, the IUPAC name of this molecule methanamide. Now for the cyclic molecules, here you can numbering from these carbon atoms, therefore 1, 2. Here at the prefix you can write the cyclic system, name of cyclic system. Here is a 6-membered cyclic system, therefore at the substituted with carbon number 2, therefore 2 cyclohexyl. Here is a ethanoic acid, therefore the corresponding amide of this molecule is ethanamides, or it also known as acetamides. These are the correct IUPAC name of these molecules. Now here the one is practice questions. You can write correct structure of this molecule and then send answer image of these compounds.